Or afternoon, everybody. How are you today? I hope you finished your last activity where you went through and you discovered the properties of the electrostatic force. So the equation, I went ahead and gave it to you before you even started last time, and it's down here on the bottom of your video. Your force electrical is equal to this constant K times first charge times second charge, and we use Q's for the charge, so that's Q1 times Q2, all over the distance between the particles squared. This, we're going to give a name to it. This one is called Coulomb's law. And again, Coulomb was just a physicist who worked to create at least pieces of these. I don't really know his history, but it'd be easy enough for us to Google. Maybe I'll make that an attendance question coming up soon. Alright, so I want to go through and practice these problems with you, and then we'll give you an assignment that'll be based on what we do here in this lesson. So I'm going through a concept builder on Physics Classroom. We've done them before in class. For this one, I have two objects that are attracted to each other with an electrostatic force of 18 units. And then we're asked if the charge of object 1 is halved, what will the new electrostatic force be? So if we think about this, we know that our force is going to be 18. And then I'm not going to bother plugging numbers in here, but we know that in our original problem, our force was 18. But what's going to happen when we multiply our Q1 by half? What will happen overall to our problem? So as I can see here, I can take that 1/2 and pull it out in front of my problem. And based on both the equation and based on what you did in your activity in the last lesson, I hope it makes sense to you that if you give one of the charges, one of the particles, only half of the charge it had originally, you're going to end up with half the force on this new situation. So I'm going to plug this in and we'll check our answer. Plug in 9, check answer, and good job us. That away. I think you remember seeing all that before. Alright, so let's try another problem. I'm going to try just a couple example problems for you today. I am starting out with the mathy part of this concept because it's so similar to what we just covered in gravity. And then I am going to back up to the concepts of what creates static electricity, and I'm going to try to come up with some fun videos for you for that. Kind of sad we don't have the time in class to play with the Van de Graaff generator, but at least my B4 class, they got some time to play with it. A3 and A4, I don't think you got so much time because we didn't pull it out. Anyway, new math problem. We have two objects that are attracted to each other with an electrostatic force this time of... Oh, forgot that was on the big size. That's what I get. Of 36 units. And that's equal to the original force. The K, Q1, Q2 over radius squared. And what we're going to do now is the charge of object 1 is doubled. So 2 times... Let's erase that. 2 times our Q1. And we're told the charge on object 2 is tripled. So, when I do that, my goal in teaching you how to play with the equations in this way is really I want you to plug in what our new values are. And then I want you to try to pull the numbers out so we get this equation back again times some number out in front. So my 2 I can pull out in front, and I can also pull the 3 out in front. And I'm going to go ahead and multiply the 2 and the 3 together. And from this I'll end up with 6 times K times Q1 times Q2 all over the radius squared. Now this K, Q1, Q2 radius squared was equal to 36. So what I'm going to get here is I'm going to get 6 times 36 if I do this to my units. And I personally do not have 6 times 36 memorized. So let's try it here. Oh, that's not a... I was thinking that was a calculator. Never mind. Let's try it here. 6 times 36 is 216. And good job us. Good job all around. Okay. I'm going to do one more of these. And then I'm going to move on to the next section in our concept builder. Okay, so we have two objects again attracting each other. This time is very similar to the first problem. This time it's doubled instead of halved. So I think hopefully you know where we're going with this. The charge of object 1 is doubled, but that is the only change made to our situation. Oh, mistake here. I should have not included the 2 here, because this is in the original problem. But then in my new problem, then I have my 2 times Q1 times Q2 all over R squared. Alright, and just like with before, my goal is to get to look like the original problem. I'm going to pull the 2 out. 2 times my equation. And I know that this equaled 18. So I have 2 times 18, or in other words, 36. Alright, so if you have questions on this part of your work, let me know. These concept questions sometimes I know can be confusing. I'm going to try next our master level, where they're going to change the separation distance instead of the charge. So in other words, changing our R, and show you what that's going to look like. Okay, so we have in this case our 2 objects that are being attracted to each other with an electrostatic force of 18 units. And that's equal to the original, KQ1, Q2 over R squared. If the distance separating the objects is changed to 1/2, so our charges are left alone, but now we have half of the radius. How will that change our new electrostatic force? So we see that this 1/2 here is inside a squared. What we can do is go ahead and square the 1/2 and the R. 1/2 squared is 1/4. R squared is R squared. Up here we have our blah blah blah. And I don't ever nobody ever likes to have fractions inside fractions. So what you're going to want to do is you're going to want to move this one upstairs. It is a legal move. I'm going to change the color here to show you this. It is a legal move to multiply by a special form of the number 1 here. When you do this, this 4 on the bottom times 1/4 is going to cancel. We're going to be left with only the 4 that's on the top. And we're just left with an R squared on the bottom. So this is going to be a trick that I do want you to try to get comfortable with, playing with the equations in this way and not just doing it conceptually. It'll help you with your number sense and some of the classes that'll come up later in your mathematical careers. Alright, so what we have now is we're going to have that 4 times our equation. So in other words, 4 times 18. I do not have 4 times 18 memorized either. So I'm going to come to Google. 4 times 18, 72. Okay. So, 72 units. And of course those units we're going to expect are usually newtons. Alright. And good job us again. We're amazing. Let's do just one more of those, and then we're going to put the two together. So, in this problem now, our electrostatic force is going to be 36 units. And now we are going to triple the separation distance. So for our new force, KQ1, Q2 over 3 times the radius squared. And from your activity, you should know that when we triple our distance, we're going to end up with a much smaller force, just like we did with gravity. Oh, I made a mistake here, because this squared does need to be outside my parentheses. And so now I'm going to go ahead and I'm going to square both terms inside. I get 9r squared. And when I look for just that KQ1, Q2 over r squared, I find that we get 1/9 KQ1, Q2 over r squared. Or 1/9 of 36. And this is the same thing, by the way, as 36 divided by 9. So, in other words, 4. Okay, so on your worksheet for today, I'm going to give you that as part of your problem. I am kind of going through the math part of things first here, and the concepts later. I apologize if the math is not necessarily your cup of tea, but I want you to be practicing with it from the beginning. And then the rest of what we do in electrostatics is going to be just talking about static electricity, and a lot of it you've actually experienced before. When I asked you what experiences you've had with static electricity, most of you talked about getting balloons rubbed on your head. It was fun to see how many of you got attacked by people that had balloons. I would have done that in class, but it is what it is. Okay, so on this case, what we're going to do is we are going to be dealing both with changing the charge and changing the distance. So I'm going to start. My electrostatic force originally is 72 units. The charge, let's not do that yet. That's equal to my KQ1, Q2 over r squared. Okay, now in my new situation. The charge of object 1 is doubled, and the charge of object 2 is tripled. And on top of that, the separation distance is halved. So we want to know what our new electrostatic force will be. Bring all of your numbers out in front, and like I said before, I'm going to go ahead and multiply the 2 and the 3 together in this process, because I think you guys can handle that mathematically. And on the bottom I've got 1/2 squared again, which is the same thing as 1/4 r squared. So this is going to take just a little more work, but not much. Not much, I promise. So what I have here is I have 6 divided by 1/4 times the electrostatic force. I'm going to focus on the number part first. We hate fractions inside fractions. So my trick here is I'm going to use a very similar but different trick to what I used last time. Instead of multiplying by 4 over 4, which I still could do, I'm going to use the trick that I think I've shared with many of you about fractions inside fractions, where I take the first fraction, in this case it's 6 over 1, and I leave it alone. And I multiply by the reciprocal of the bottom fraction. Some of you have heard me use the example before that I am the oldest in my family. I'm the first. I have a sister who's the next daughter in my family. She's the second. And one of my favorite things to do is, ever since she was about 2 years old, is I like to sneak up behind her and I like to flip her upside down. So I, as the first one, I do not get flipped. My head stays where my head stays and my feet stay where my feet stay. But my poor little sister, she gets flipped upside down and her head and her feet switch directions. It's the same thing that happens with math very conveniently. Alright, so 6 times 4 gives me 24. So I am going to have 24 times my electrostatic force. 24 times 72. Let's see what that is. 1728. Can barely see it for all of my work. I'll go ahead and erase this time first. And there we go. Okay, so for your homework today, I'm going to have a worksheet for you that has problems like this. And I'm also going to get you started a little bit on the static electricity and the different methods that we can use. On Canvas, let me pull it up for you. On Canvas, I do want you to go ahead and do the aluminum can polarization. I'll put it into our lesson and assignment, which will have this video as well. And I do have a worksheet I want you to do just to show me what's happening to the electrons in the different scenarios that are listed. I will be talking next class about charging versus, or the two primary ways to charge objects. And this will actually be a pretty short section. Let me know. Go ahead and I'll make this an attendance question too. I'll try to remember to do this, but be thinking about it. Let me know if you would like to have several small tests this quarter, or if you prefer to have just a couple big tests. I'm good with either one. As long as we're separated, all of your tests will be open book. So just let me know what you prefer. Anyway, I hope that you are having a wonderful, wonderful day and that you're staying safe. Remember, I do have office hours every day, every school day from 11 a.m. to 1 p.m. if you need anything. I'll also check my email off and on throughout the day, but from 11 to 1, I'm at my computer just waiting to see if anybody has questions. And yeah, let me know if there's anything you need. I will be talking to you again soon. I'm looking forward to our next couple lessons. These ones I like because I like the math, you know I do. But I think you'll have some fun with these next couple lessons too, hopefully. So I will talk to you later. We'll see ya. Bye.